All right, this is part 3 of our polynomials unit. We are going to be looking at algebra tiles today. So, representing polynomials pictorially. Before this video, you may not have an idea of how to represent this pictorially. Now, there's plenty of ways to do it. What we're going to show you in this video is a manipulative that we call algebra tiles. So represent the following values visually. Let's start with the number 3. How would you represent this visually? Well, someone could say 3 coins. Someone can just say 3 tables. We're going to use squares. So I have 3 squares here to represent 3. Now we can show 5 with 5 squares. And negative 7. Well, it is negative. I owe 7 squares now. So I need to color code to represent something I owe instead of something I have. So here's my color code. I'm using red for negative. So I'm in a deficit of 7 squares. Represent the following values visually here. Again, we have 2, but this time I'm going to stack them. Here we have 5. I'm going to stack it. Makes it look nice. And now we have x. How do we represent x visually? Well, I could just keep going, maybe with some blocks. Let's find out. Well, it depends on what x is, I guess. So, depends on how many blocks we have. It could be less, though. It could just keep going to infinity. Why don't I just create a rectangle where the number of boxes in that rectangle are unknown? We'll call that x. All right. So represent the following values visually here. 2x, 2 sets of x. So I take those 2 rectangular blocks that we made for x and just put them beside each other. 4x. We got 4 sets of x. That's what multiplication is, sets of. Negative 3x. Now again, we're going to use a color code. I owe 3 x's, whatever those may be. We're going to review some multiplication again. So remember, multiplication creates a product. So 2 sets of 3. There's my set of 3. And 2 sets of 3 will make 6. So you can see here 6 blocks in total. So this is going to say 5 sets of 6. And so I'm going to have a set of 5 and a set of 6 on the bottom. And I just fill it in. That's what multiplication is. It's creating a field of blocks, a product of blocks. Now, if I had x times x, well, I don't know how many boxes x has, so I don't know how far it should go down. I also don't know how far across it should be. But I do have a visual for it. There's my rectangular block. And I'm going to multiply it by x. Now we're going to fill our field. When we fill the field, it'll just become this big square. Now, you know it's a square because the length and width are going to be the same size. That's why we're going to call it x squared. So let's take a look at 2x squared. Well, I'm just going to take 2 of those boxes, the big ones, x by x. 3x squared. 3 of those boxes. And finally, negative 2x squared. I now owe these boxes. So now I can take a polynomial, or a picture of a polynomial here, and represent it. So you can see my 2 x squares, so there's 2x squared, my 1x, and my 1 value. Now you try. So I want to give you some questions. I want you to pause when you can before I give you the answers, and try these questions on your own. So if I was teaching in a classroom right now, I'd pass out algebra tiles for you to use. They would be just little blocks that represent the squares and the rectangles and the smaller blocks, and you can use those for algebra tiles. So we're going to represent 3x squared plus 2x minus 8. So there I have my 3x squareds, my 2x's, and negative 8 there. Let's try this one. So negative 2x squared minus x plus 5. And that's concluding our introduction to Algebra-tiles. We're going to be adding polynomials and subtracting polynomials in our next video. Thank you for watching.